What's up, guys? Let's take a look at another CodeWars exercise, or really the same one, again in a different language. Yesterday we checked out the even or odd with Rust, and we saw that it can do an if-else style, or it can use the pattern matching match, and then you list the cases. And I heard that Haskell has even more serious pattern matching, so I wanted to try it out. This is the same exercise with Haskell. So you see the syntax here. It looks a little different. We've got a function called even or odd, and it takes an integer and then it gives you a string. Same idea, same general flow of input to output. And then we define the specifics. So one thing that I thought was really cool is that you can just define a couple examples. It's almost the opposite of what I usually say whenever I'm talking to someone about how humans learn by example wonderfully. If I want to see something new, I tell you to give me examples. But computers don't. You have to give them the general rule rather than here are 2 or 3. But that's not always the case. So let's see here that we can do some examples and then have the compiler extrapolate from there. So for example, what if I said 0 is even, okay? 1 is odd. And I say, hey, these are specific cases. If it's 0, it's even. If it's 1, it's odd. And then I can say, well, just if you don't get one of those, move toward one of those. So I could say even or odd n, which is like if you didn't catch the 1 or 0 and you're still left. I think, I'm not certain about the syntax, but let me try. Then we just go n minus 2, which is like, hey, if we've got a 3, well, it doesn't hit the 1, it doesn't hit the 0. Try doing minus 2, and then you put it through the same function, and you're like, oh, well, now it's getting closer. And if you gave it 1,000, then well, it would take a bunch of steps. You'd have to minus 2, minus 2. So this is obviously not efficient, but let's try to test it and see if I got the right syntax. I might need parentheses. Let's try that. As you can see, generally in these functions you don't need parentheses all the time. You can just say even or odd 0, and it's clear that that's the input. So you could see that we got some. This actually did work in general. Like if you give it 3 or 4 or 5, it's totally fine. But it timed out because they do try big ones. They say, what if I gave you 1,000,000 and I want you to tell me if it's even or odd? Well, this would take all day because it would go minus 2. Is that fitting the pattern? No. Okay. Minus 2. Is that fitting the pattern? No. Okay. And it would keep going all the way until it hit 0 or 1, which does happen, but not nearly fast enough. So let's try a different way. Now, Haskell has a modulo just like Python. So we could say, I think it's something like in mod, and when I look this up, it has these backticks on the mod, and I don't know what they mean. I didn't look up the specifics here, but I would guess, if I just had to guess, that it has something to do with the fact that it goes in the middle of its 2 inputs rather than on the left like most functions. I would imagine they need some type of special syntax to say, hey, this is an operator that goes in between the things rather than, you know, like sum of A and B. And then you could use if and else. So we could say if it's 0, then they actually use the word then, which is nice. Then we say even, else we say odd. I think that would work as a nice expression. And it did take a second. You saw that it kind of slowed down, so maybe there's a more optimal way. But we could use this as our answer. However, there's another one I wanted to point out, which is using that pattern matching idea. We can say, okay, let's branch into two directions, and they use the, I think they call it the pipe operator here. So we could say in mod 2 is 0, then we get even, and then this part is lovely. It's the else, like the catch-all, the miscellaneous at the end. In Rust we used an underscore, in Python we say else, and in Haskell they have this keyword otherwise, which I think is just so cute. It's very English, you know, it's very natural. They don't want to use math terms, even though Haskell is a very mathematical language. They want to use nice words. So we could say, okay, otherwise it's odd. And then if I test that, I think I may have done some, oh, I need to take off the equals here. I may have done some of the syntax wrong because I'm not familiar with this language, but we're getting there. Do I need a comma or something? Maybe I just need to indent that differently. Ah, dang it. Let me see. I had this on another screen and I'm just going to copy it over. Well, that looks the same. Oh, that one worked. I must have done some kind of typo on this where even though it looked the same, I had some issue with an extra space or the indenting off. So let's check the solutions from other people and see how that goes. Here's one that uses the pattern matching, but it has an even function. They say, I don't even need the modulo. I can just ask, is this even or not? Because apparently there's a built-in even that gives you true or false. These guys use the same thing with the conditional if-else. This one used odd. Guess what? There's an odd function, and you give it a number, and it tells you yes or no if it's odd. And this guy did the example. I don't know what they call this specifically, but where you give it a couple examples, and then you give it how to reduce down to one of those. And instead of the -2, which was inefficient for our purposes, they used the modulo to get there quicker because you're dividing instead of subtracting. And as we see, there's a new way to combine these every time, but it's the same idea. You can have the if then else, you can have the examples, you can have the pattern matching with the pipe setup, and all of these are kind of nice. Look at this person said, what if we don't get one of those two? What if some crazy input doesn't work? Well, we can have a fallback, we can have an error to say, hey, notice me, make sure you fix me before the function gets used, because apparently it doesn't catch all the possibilities. And that's really nice because you could build onto this, just like the modulo was used as part of this, and the even odd could be used as part of this. You can now use this as part of other things. Probably not as easily, because returning a string is not as good as returning a nice number or Boolean that can flow into the next thing. But it could, as if it's going to be part of a sentence or something. So I wanted to show that, hey look, here's another slightly different approach where they take these two in a list or a tuple, whatever they call it with the brackets, and then they index into it, which is either 0 or 1. So that's great, and we could do that in the other languages too, we just never thought about it. This is a way to treat the same question in different languages and see what ideas are brought up by each one that you may not have seen from the others. And then when you go back to Python or you go back to whatever, you can think, my world is expanded. I have a few more branches to go down, even if I still end up using the familiar ones.